Hello, so here we are for our first set of notes. We're talking about page 4, graphing a standard form equation using decimals. So the first thing I want to remind ourselves is, what is standard form? Standard form for a quadratic equation is always going to be in the form of ax squared plus bx plus c. Where a is, we call that our leading coefficient because it's in front of the x squared terms. It's a number. B is in front of the x term, and c is our constant. It's a number that's by itself without a variable. And you can see this either as equals y or equals f of x, like we have here. Those are two different versions of it, mean pretty much the same thing. So the first thing we're going to do is we are going to identify, using just the equation, the vertex. And if you guys remember, that is that middle point, that point where it goes from either going up to going down, from down to up, the top point to the bottom point, depending on which way it's facing. And we have a specific formula that we can use to find the x value of that vertex. It is x equals negative b over 2a. So the question is, what is b and what is a? So there, we're going to look right here. So we have our negative 8 in the spot where the b is. So the opposite of b, opposite of negative 8, is going to be a positive 8 over 2 times the leading coefficient, which is the a. So that's going to be 2 times 2. This is going to give us an x value of 8 divided by 4, which is 2. That is going to be the x value of our vertex. That does not tell us the y value. The way we find the y value is to plug that x value into our equation. So I'm going to say f of something equals 2 times something minus 8 times something plus 3. That's going to, now all those somethings, we're going to plug in that 2. F of 2 equals 2 times 2 squared minus 8 times 2 plus 3. That is going to give us the y value that that belongs to that x value, is associated with that x value. So that gives us negative 5. If you just type that in your calculator, or you do the math on your own, you should end up with negative 5. And that goes right here. So I have the point 2, negative 5. That is going to be either the top point of my parabola or the bottom point of my parabola. Now, a parabola is symmetric. On either side of those points, you are going, of the parabola, on either side of the vertex, you're going to find points that are symmetric. So what we're going to do to find other points to graph here, I am going to go one space to the left. So 2, one space to the left is going to be a positive 1. And one space to the right would be a 3. And now I'm going to find the y values that go along with those x values. Same way I did with the 2. So I'm going to do f of 1 equals 2 times 1 squared minus 8 times 1 plus 3. And I'm going to do f of 3 equals 2 times 3 squared minus 8 times 3 plus 3. So I get f of 1 to equal negative 3. So that's going to go here. And f of 3 to equal negative 3 again, which should not be a surprise. If it is symmetric, then those should match. If you go the same distance from the vertex on the x-axis, then it should be the same on the y-axis as well. So let's go ahead and plot those 2 points so we get an idea of what this looks like, or those 3 points. 2, negative 5 is our vertex. That goes right here. And then 1, negative 3, and 3, negative 3. So far, it looks like it's a V or a triangle, but if this is our vertex, we can sort of imagine this is going to be facing up, and there's going to be more points. We're not going to connect them as a triangle. That doesn't make sense. It's going to be a parabola. It's going to face up in that direction. So the equation of the axis of symmetry is where we would fold it so it matches up. And that is always, always, always going to go straight through the vertex. It's going to be a vertical line that goes straight through the vertex. And that means that it's an extremely easy thing to write because I already did it. The vertical line is x equals whatever the x value is of that point, and we know what that is. It's x equals 2. So once you know the x value of the vertex, it's always going to be the equation of the axis of symmetry. They're always the same. X equals 2, x equals 2, and that's it. All right. The y-intercept is what's next here on our list. The y-intercept is where it crosses the y-axis. And the thing about the y-axis is the x value is 0. So we are going to do that the same way we found these other points. We're going to say f of 0 this time because I know the y-intercept is always going to have a 0 for the x value. And I'm going to plug in that 0. 2 times 0 squared minus 8 times 0 plus 3. Now something interesting happens here. 2 times 0 squared is 0. Minus 8 times 0 is 0. So all I'm left with is that 3. Do you think that's a coincidence this time? No, because I just said we're always going to plug in 0, which means that the first term will always be 0. The second term will always be 0. And the only thing we really have to worry about is that plus 3 at the end, or whatever that constant term is. So from here on out, we're not going to go through this. What we're going to do is we're going to look at the constant term of our equation, and that is what our y-intercept is. Because it's always going to be 0, plus or minus 0, plus or minus that number, which is just going to end up being that number. So this right here is your y-intercept. You have to write it as the point 0, comma, that number, but that is the y-intercept. Now, does the function have a minimum or maximum? We can see right here, it has a minimum. Minimum. And what is that value? That is easy to find as well because we already found it. The value is always going to be the y value of our vertex because that was our output at that point. So that when we plugged it in, we got a -5. That's the output. That's the value of the function at its lowest point. So that is a -5. So from here on out, you're always going to know that this y value of your vertex is always going to be the value of either your max or your min. No other point would be it. The shortcut way of figuring out if it's a minimum or maximum without looking at the graph is we look at our leading coefficient, right? In this case, it's a 2. What's important about that is that it is positive, which means that it is concave up. It's going up, it's getting bigger on both ends with that positive number, that positive coefficient. And that means that this point right here at the bottom, the vertex, is a minimum. Okay, so we're just going to use that number, that leading coefficient, to tell us whether it's a min or a max. Now, the zeros are the functions. This last one, this is when we're going to go ahead and look at the graph. And we're going to use Desmos. So hold on a second. We're going to switch over there. Hi, so I'm back. So we're on Desmos.com. If you just look up here, just Desmos.com, and we're going to click on the graphing calculator. It's a really useful tool. So up here, we're going to type in our equation. We're just going to type in y equals 2x to the second power, arrow over to get you out of your exponent there, minus 8x plus 3. And here we have our parabola. It just pops up for us, and I love how clear everything is. Right here, we can verify that we have our vertex correct, 2, -5. We can see our y-intercept is correct, 0, 3. And another thing to notice is that if we look over here at 4, 4, 3, if you can get it on there exact, is also a point, which shouldn't be a surprise because our axis of symmetry is right down the middle. So we can plot those points 0, 3, and 4, 3 on our graph as well. What we're looking for here, though, is our zeros of the function, and that is when the value of the function is 0, when the y value is 0. So these are always going to be marked for us already. We don't have to try and scroll right there where it crosses the x-axis. 0.4190. I'm going to write that on my paper so I don't forget. 0.419 comma 0. And then the other one right here, 3.581 comma 0. So you can see the zeros are not always nice, pretty numbers. These are actually going to most likely be decimal approximations most of the time for quadratic, okay, unless they just happen to be nice numbers, but you can just use decimals to find them right there. And there we have it. Our graph is facing up. We have our minimum, which is our vertex. We have our y-intercepts. Our y-intercept and our x-intercepts, which are our zeros. So we're going to head back now to the paper. All right, so now I wrote those 2 points down here, 0.419 comma 0 and 3.581 comma 0. And I am going to plot those on my graph. They're going to be estimates because they're decimals. So about halfway through there and about halfway through here. I'm also going to plot my 0, 3, which is my y-intercept, and the corresponding 4, 3 over here. And now I can see I've got this nice looking parabola. The last thing I want to remind you guys to do is anytime you're drawing a parabola, do not connect the points with straight lines. Even though it looks almost just like a V, this is a curve and you have to draw it as a curve. So try to connect your points as nicely and as smoothly as possible. If you're making the effort to make sure it's a curve, I'm not going to get mad at you if it looks a little wonky. But if you connect with straight lines, I'm going to count that wrong because that is incorrect. It's not a straight line. All right, there we go. That's our first example. Hopefully the other examples are going to go a little bit quicker. So now that we know our shortcuts, let's go right here. Our vertex is first. We are going to find our vertex the same way we did before, negative b over 2a. So x equals negative b over 2a. So that in this case, the negative b is negative 5, so I'm going to put a positive 5 over 2 times my a is a negative 1, so I'm going to put negative 1, which gives me a negative 2.5 for my x value. Okay, so I'm going to put that right here, negative 2.5. And before I forget, this is also one of these other options. This gives me the same. Which one does it apply to? Right, it is also the axis of symmetry. So I'm going to write right away, before I put down my blue marker, x equals negative 2.5 as well, right there. Those two things are always going to be the same, the x value of vertex and the axis of symmetry. Now I'm going to use my function to find the y value of my vertex. Notice I am using parentheses. I put my negative on the outside of the parentheses. That is important. If you don't do that, you will get the wrong answer. So I'm going to put negative 2.5 in all those spots. Oh, f of negative 2.5, that's what I'm looking for. So this is going to give me my y value for the vertex. And when I type that into my calculator, because I'm not doing that in my head, I get 13.25. Okay, so that goes right here. And that y value should go somewhere else. Where else does that y value go? Goes right here. It's always going to be the min or the max value. The question is it a min or is it a max? That's the next question we have to ask ourselves. We look at A, whatever's in front of the x squared. Now, all it is a negative, but that's all I need to know. It's negative. And does a negative a value indicate that it's concave up, facing up, or concave down, facing down? It is concave down, which looks like this. It's pointing to the negatives, which means that's a maximum. That's the highest point. So does the function have a min or a max? I know it's a maximum because it's a negative right here. It's the top of my graph. And so I'm going to circle max here, and I know that the max value is 13.25. The next thing on my list is the y-intercept. I am not going to do any calculations. I'm going to look at my equation. Do I look at the a, the b, or the c of that equation to find my y-intercept? That's right. I am going to look at the c, the plus 7. So remember, the y-intercept is always 0, comma, always 0. And then whatever that, when you're in standard form, whatever that constant is right there is your y-intercept. All right, so now we just have to find the zeros. Let's find them. I'm gonna look at the graph. Okay, here we are on the graph again. We are going to type in our equation, y equals negative x to the second power minus 5x plus 7. All right, oops, I gotta zoom out, drag this down so I can see the whole thing. Let's check our vertex, negative 2.5, 13.25, that's what we got. Check our y-intercept, 0, 7, that's what we got. Notice that we have negative 5, 7 as well. It's gonna help us graph, negative 5, 7. If you can drag it, it'll get there. And then now we're looking for 1.14, comma 0 and negative 6.14, comma 0. So those are our two zeros where it crosses the x-axis. All right. So those are the points that we had: negative 6.14, comma 0 and 1.14, comma 0. So now let's go ahead and sketch our graph. The first thing I'm always going to plot is my vertex. And oh, look at this mistake by your teachers here. Anybody notice a problem with this graph? It only goes up to 8 in our vertex at 13.25. Never skip the vertex. We're going to change the scale. I'm going to count by 2s instead. So it's 2, 4, 6, 8, 10, 12, 14, 16. That's the easiest way. I'm not going to need the negatives because I'm going to plot all my points are positive, but that will go there too. Okay, so we're going to plot our first point, which is our vertex, negative 2.5 and all the way up to 13.5. So this is 12. And so it's going to be right about there in the middle of negative 2 and negative 3, and slightly closer to 14 than to 12. Just slightly, though. Our y-intercept, I can plot at 0, 7. And we said our corresponding value was at negative 5, 7. So we can plot those. And we also have our zeros at negative 6, 1.4. So that's about here. And negative 6.14, comma 0. And 1.14, comma 0 is over here. So you can see this overall is wider than the first one. And that's because on that first one, we had multiplied by an integer. And it makes the parabolas skinnier. Since here we only multiplied by a negative 1, it is the standard width. Okay, so you can see it's a little bit wonky, but that's okay. Do your best. Next example. Number 3. Find the vertex. X equals negative b over 2a. So x equals positive 6 over 2 times negative 3, that's going to give me x equals negative 1, which means that's the x value of the vertex. It's also going to be my axis of symmetry. Have that done already. Now I'm going to plug in f of negative 1 into my equation. Take that x value that I found, plug it in, and I get f of negative 1 equals 0. Okay, so I got my 0 there. I know that's also going to be either my min or my max value. I plug those numbers in right away, and now I look and I say, is it a max or is it a min? Get your leading coefficient. It's negative, which means it's concave down, which means we have a point right at the top, which is our max. So it's a maximum. So I'm going to circle it right there. Y-intercept. I'm going to look at the constant term, that minus 3 right there. That's going to be my y-intercept, because when I plug in 0 here, it's gone. 0 and then minus 3. So I have my y-intercept is the point 0, negative 3. And the zeros of the function, now normally we'd go to the graph, but I actually know what the zeros of my function are already. And that is because if you look at your vertex right here, it's negative 1 comma 0. So that's a 0 of the function. Oops, negative 1 comma 0. It just so happens that the vertex of this graph is on the x-axis. So if I go negative 1 comma 0, that's the only time it's going to touch the axis, because it's going down to the left and down to the right. So it only has that 1, 0. If your vertex happens to be something comma 0, it is the only 0 of that function. So we also need to plot our 0 comma negative 3, and which means that if 1 to the right and 3 down, then it's going to be 1 to the left and 3 down, because our axis of symmetry goes right through the vertex. Oops, did I do that right? Looks, yeah, okay. And this graph, if you did look at the on Desmos, the next nice looking point is way down, because this is a very skinny graph parabola, because we're multiplying by that 3 right there. So I'm just going to go ahead and connect. Even though I only have those 3 points, I am not using straight lines. I am just going to make it ever so slightly curved. And there we have it. It's going down. I have my maximum value of 0. My y-intercept is 0, negative 3. My x-intercept, or my 0 of the function, is negative 1, 0. There we go. All right, next we have some u-tries. And now this is problem number 4. I want you to pause the video for a second and use your notes. And I want you to try this problem. And in just a second, I'll come give you all the answers so you can check your work. All right, so your answers, you should have gotten, your vertex would have been 1.25 comma negative 0.125. We're going to do that the same way we did before, by plugging in x equals 5 over 2 times 2, which gives us 1.25. And then we plug in 1.25 into our function. Which hopefully you did. And that's going to give you your negative 0.125 for your y value. The axis of symmetry is x equals 1.25, and you must write the x equals. Don't forget that. It can't be just the number. But the y value of your vertex is just the number, negative 0.125. We look at the 2, which is positive, which means it's facing up, or a concave up, which means we have a minimum. And that's how we decided that it's a minimum value of negative 0.125. The y-intercept is the constant at the end, so that's 0, 3. And when you graph this using Desmos, you would have found 2 zeros very close together, 1, 0, and 1.5, 0. Really close together. 1, 0 and 1.5, 0. And your vertex is right there. Oh, so close in between. So this just barely dips under the x-axis. Those points are super close together. So that's impossible to try to guess what the graph looks like, what the parabola looks like just from those 3 points. So I'm also going to make sure I do my y-intercept at 0, 3. And then the corresponding value isn't at 3, 3. It's actually at 2.53. And you can verify that using Desmos, or you can just say, well, 1.25 away to 0 plus 1.25 gets you to the vertex, and then 1.25 plus 1.25 gets you to 2.5 value there. But Desmos is also easy to verify. And now that gives us a little bit more structure to graph, and I can draw my curved lines here. And your arrows are always going up and out or down and out, just ever so slightly sometimes. Okay, hopefully you did well on that. If you have questions, make sure to put big stars next to them so you can ask me in class. Number 5, this one should be pretty straightforward because we've been doing this already. It's just a little bit less work. It says, tell whether the function f of x equals 3x squared minus 18x plus 20 has a maximum or a minimum. We can do that. You look at the 3. That's positive. Means it's going up, which means it's got a low point. It has a minimum. Okay. And then you got to find the value of that max or min. So the first thing we have to do is find the x value of the vertex and then use that to find the y value of the vertex. So let's do it. X equals negative b over 2a. The b value is negative 18, so that's going to be a positive 18 over 2 times the a value, which is 3. 18 divided by 6 is 3. So I get x equals 3. And I'm going to do f of that 3. Into my function. So I'm going to say f of 3 equals 3 times 3 squared minus 18 times 3 plus 20. And I should have gotten f of 3 equals negative 7. Okay, so what I'm going to write is, to answer the questions, let's find the value of the max or min. I'm going to say min value equals negative 7. I'm going to put a nice box around that answer so it's very clear what that answer is. All right, next we have another you try. Same idea as this. And you actually have 2 of them. So pause your video and try problems 6 and 7. All right, for question number 6, your final answer should have been in the max value equals negative 4.75. And question 7 should have been the minimum value equals 6. Okay, oops, let's see. Now, if you got those perfect, go ahead and be done with your video. If you made a mistake, I'm going to go over how to get those answers now. But yeah, if you got them correct, I'll see you in class. Bye. All right. So for those of you still hanging on, we're going to go over here and we're going to look for the x value of our vertex because the max value always happens at the vertex or the min value. So we're going to look for x equals negative b. So look at our 6. The number in front of our x value is, so it's going to be a negative 6 over 2 times negative 4. And that's going to give us a negative 6 over negative 8. Negative over negative is positive, so that's a positive 3/4. Or if you prefer, and probably easier if you're using your calculator, 0.75. That works too. And then we're just going to plug that in, f of 0.75, And I'm going to rewrite all of this. 0.75, 0.75, and 0.75. It goes in all those spots. So f of 0.75, now I just have to type this part into my calculator, negative 4.75 squared. And that's going to give me a negative 4.75. All right, so that's how I got that number. The y value is the max or the min, but how did I know it was a max? I'm always going to look at my a value, that very first thing in front of the x squared. And I don't really care about the number. I just care that it's negative. It's negative. And in a negative quadratic function, that means the arrows are pointing down because that's in the negative direction. And if the arrows are pointing down, that means the vertex is on the very top. So that means it's the maximum. And that's how I got max value is negative 4.75. On the last problem here, same way, x equals, and now I've got negative 10 for my b value. So I'm going to put a positive 10 over 2 times the a value, which is 5. And that's 10 over 10. That's just going to give me a positive 1. I like nice numbers like that. So that gives me, that'd be my axis of symmetry, but that's not what they asked for. So I'm going to do 5 plus 11. I'm just going to plug in that 1. F of 1 equals 5 times 1 squared. That's 5 minus 10, which is negative 5 plus 11. And that gives me a 6 for my final answer there. It means the y value of my vertex is 6. That's how I get there. 6 is the value. I look up at my coefficient of the x squared. My a value is a positive 5. If it's positive, that means the arrows are pointing in the positive direction, and my parabola is facing up, and I have a lowest point, which is the minimum. And that's why I have a minimum value of 6. I hope this was helpful. Please make sure you mark down any questions that you have, and I will see you in class. Bye.